Hi, I'm Jeremy, and today we're going to build an AI agent grounded in this knowledge graph without writing a single line of Python code. Now, this graph looks imposing, but the structure is actually pretty easy once we look at the schema. This is a graph that represents an entire course on generative AI from our Graph Academy. And we can see we've got various lessons and PDF documents that we extracted chunks of and then pulled out entities like concepts and technologies. So that's really it. Let's take a closer look in the graph itself. I'll zoom in. Same color coding applies. So here we have a lesson in purple and the PDF document of that lesson that is broken up into chunks. And each chunk is literally a chunk of text as well as a vector embedding that represents the semantic meaning of that chunk. And here's the first chunk, the second chunk, and so on. We can also see the entities that are hanging off of these chunks. They're extracted from them. And this one is the concept of randomness. Awesome. Now, let's see what a conventional Python agent looks like to work with this graph. Typical for just about any agent framework. A whole lot of imports and boilerplate. Really, an agent is just an LLM with tools in a loop, trying to solve a problem presented by the user. So let's find these parts. Here at the top, we can see the LLM model. And then a little further down, we can see 3 tools. So we really are just going to focus on this search lesson content tool. Now, this one uses a combination of vector and graph traversal. It's a vector Cypher retriever. And it uses a particular vector index and a retrieval query written in Cypher right here that's doing a lot of the work. It's going to retrieve the top K chunks that are similar to our query, and then is going to apply this bit of Cypher to get neighboring entities that are going to be related to those chunks. That'll be great context for the agent. In fact, this is going to pull back for a given chunk that's from a document and is in a lesson, the chunk's text, how good of a match it was based on cosine similarity score, as well as giving us the lesson URL we could direct a student to. And then it's going to take that chunk and give us the entities and how they're related to other entities, perhaps from other chunks. Again, great context for an LLM trying to answer a question about the lessons in this course. So let's just grab this bit of Cypher. Remember, the goal is not to write any Python, but we might write a little Cypher. That's allowed. So let's go back and go to the agents interface here. So I've already started an agent right here. Let's go ahead and hit configure to take a peek. All I've done so far is give a name, description, and a prompt instruction. I've picked out which database I want to use, and I've got one tool given to me for free, text to Cypher. And in fact, it will check the schema of the database first, so it's like 2 tools in one. Well, let's add one more tool. And is it a Cypher template? Well, that would be if I just wanted to have a canned Cypher query and maybe have the LLM fill in some parameters. Those are great, but not what I want here. Instead, I want this similarity search tool. This is going to allow me to pull some chunks via a vector index and then run some Cypher to get connected graph data. We can paste in this query as is because we're going to get both a node and a score provided to us for free. So this query will work as is. Now, to help me fill in some of these details, I'm going to go back to this document where I've got them stashed as comments on this tool. So I'm going to give this name of search lesson content, and then I'm going to grab this line here to be my description. We're going to select a vector index, which I've already prepared, and we're going to pick the top 5 chunks. I'm going to use the same embedding provider I used to create the knowledge graph, and we're going to say add tool. Now that we've done that, we can update the agent and give it a try. I should be able to ask questions like, how many lessons are there? And we don't expect that to use the lesson lookup tool, but rather some kind of ad hoc Cypher query. So here we see natural language decipher being run, and it says there are 15 lessons. We can even see how the LLM did it. It created that chunk of Cypher that we can test for ourselves right here. Sure enough, we got 15 as well. Going back, we can ask another question. How is temperature related to LLMs? Now this sounds like something that might be in our lessons, and indeed we're using the search lesson content tool. After pulling some chunks and some nodes, we see that temperature controls the amount of randomness that an LLM uses to generate. And we got some handy lesson URL links here so we can explore further. So as you see, without writing any Python code, and just a little Cypher and configuration, we're able to create an AI agent grounded in the knowledge graph, which is a lot better than all of this boilerplate. So what's next? Go spin up an Aura instance for yourself. There's free ones. And go over to the Agents tab and create your first agent. If you don't have any Cypher yet, you can even create an agent with AI. So I can't wait to see what you build.